Hello friends, in this video let's look at this fun kinematics problem. It's quite simple actually, but maybe a bit tricky as well if you didn't analyze it in the right way. Anyway, let's look at the setup. So there is an unstretchable string and the pulleys are fixed. So there is this string is unstretchable going over these two fixed pulleys. Then there is a block and these strings connect to the block. The two ends of the string are being pulled down at this uniform speed VR, so there is no acceleration. There is a constant speed at which these ends are being pulled. These slant parts of the string in the center make angle theta each with the vertical, so things are symmetrical here. We need to calculate the expression for the speed at which the block moves upwards in terms of VR and theta. Let's say this is the pulley. This is the block. Similarly on the other side as well. Let's look at this right angle triangle. So this distance of the pulley from this vertical line, let's call it x. Let's say this length is L and this height is h and this is the angle theta. If this end is being pulled at speed VR, so the rate of change of the rate at which new string arrives at this end of the pulley is the same rate at which a string is essentially moving over from here to that end. So VR and the rate of change of L with respect to time are the same quantities. So dl by dt equals VR. Hope that is clear. We need to calculate the speed of the block, which is nothing but the rate of change in h. So what we need to calculate is Vm, which is nothing but dh over dt, and this is what we need to calculate. Another thing, if you notice, as this movement will unfold, as the block will move up from here to here, let's say the block reached here, then this will be the new length L, which will be different from this current L. So as the movement unfolds, this L changes. Similarly, h changes because obviously the block is going up, this length is going to change. Theta will change as well because let's say at some point the block is here, and this angle is going to be different from what is this theta here. What doesn't change is x. Regardless of where the block is, the distance of the pulley from this vertical line does not change. That is the key thing we'll use in the solution. So if this is a right angled triangle, L square equals h square plus x square. Hypotenuse and the two other sides of a right angled triangle. Do the differentiation of both sides of the equation with respect to time. We get d dt L square equals d dt h square plus d over dt of x square. This implies that 2L dl dt equals 2h dh over dt plus 2x dx over dt. Now x does not change at all, so hence dx by dt is 0. dl by dt is given to us as VR, dl by dt is VR, and dh by dt is our Vm that we need to calculate. So this implies that 2L times VR equals 2h times Vm. This implies that Vm equals VR times L by h. Now if you look at this right angle triangle again, let's draw this again. L, x, h and theta, then the relationship between L and h in terms of theta is that cos theta is h over L. So L over h is 1 over cos theta. So this implies Vm equals VR over cos theta. And this is the answer. Let's solve the same problem in another way as well, while using the same principle, which is that x does not change with time. That is the key idea here. So this is the triangle x, L, h and theta, and we know that dl over dt is VR and dh over dt is Vm, which we need to calculate. Now we can start with this time. Let's start with, so this is a new, a different way to solve the same thing, essentially the same thing, but just structured in a different way. So we can see that from this triangle, cos theta equals h over L. So this implies that h equals L cos theta. Now if we, now all the three quantities in this equation, h, L, as well as theta, they change with time. As the block here goes up, L changes, h changes, as well as theta changes. So if we differentiate the both sides of this equation, we get dh over dt equals cos theta times dl over dt minus L sine theta times d theta over dt. This is d theta over dt. So this looks good, something we need. This is something given. How do we get rid of this? So let's see. From the same triangle, we can also see that sine theta is x over L. So we can write sine theta is x over L. This is equation number 1. So this implies that x equals L sine theta. Let's differentiate both sides. This implies that dx over dt equals sine theta times dl over dt plus L cos theta d theta over dt. Now let's apply the same principle. As we know, in the scenario of the problem, x does not change. So dx over dt is 0. So this implies that 0 equals sine theta dl over dt plus L cos theta d theta over dt. So this implies that d theta over dt equals minus sine theta over L cos theta and dl over dt. Let's call it 2. So substituting value of d theta over dt from 2 into 1, we get dh over dt equals cos theta dl over dt minus L sine theta minus L sine theta, and then d theta over dt is minus sine theta over L cos theta dl over dt. A lot of terms. But the good thing is, now we have eliminated all the unwanted variables. This dh over dt is what we need to calculate. Dl over dt is given to us. L and L cancel out as well, so we got rid of that also. So theta is the only other variable, and which we are allowed to use in our answer. So this implies that dh over dt is Vm from the diagram. This is Vr cos theta minus plus, because minus and minus multiplied become plus, sine square theta over cos theta Vr, and equals, so we take Vr common, this becomes cos square theta plus sine square theta over cos theta, and sine square theta plus cos square theta is 1, that is a trigonometric identity, and hence Vm equals Vr over cos theta, which is the same answer that we arrived at using the other but probably much simpler method. Thank you.